Good evening. My name is Lawrence Saint-Onge. I'm the chair of SMPTE Toronto section. I would like to welcome everyone to another amazing meeting. Tonight, our sponsor is SMPTE Toronto for the Toronto Conference, Technical Conference for 2024. The topic for tonight is Modern Infrastructure and Media Business Model Impact. It's arranged by Noor Assam and Silvano Malmedia. Our evening protocol is each presenter will share their presentation. Question will be during the panel discussion. Virtual Zoom Quest, please use the chat box and no break between the presentation. Our presenters are Karen Foreman from Amazon Web Service, Maran Habal from Matrox, Vinicius Galera from Media Monks, Stephen Sutton from Diversify, and Roger Baijo, Data Miner Skyline. So without ado, I will present how modern infrastructure influence media business by Silvano. I think Silvano will have to chat about that a little bit. Please go.
Thank you, Lawrence. Good evening, everyone. Welcome to the May SMPTE meeting. So my name is Silvino. So I and my colleague Noor, we would like to welcome you today for the SMPTE meeting. So the topic we picked for today is something that is at the edge of the new technology and the new challenges that the media business is facing, right? So today you delve into this fascinating intersection of media and infrastructure and its profound influence on the media business model. If you go back to the early days of television, television was a one-way medium, with broadcasters controlling the content and viewers passively consuming it. The infrastructure supporting this technology was simple, consisting of transmission towers and broadcast studios. As technology advanced, so did the television. The introduction of the playback, the cable TV technology, satellite broadcasting expanded the reach and capabilities of this medium. With these advancements came the need for more sophisticated infrastructure to support the growing demands of the industry. That was the age of mass advertisement. In today's world, the digital revolution, the internet, the digital technologies revolutionized how you consume media. The rise of streaming services, on-demand content, and digital distribution platforms reshaped the media landscape, blurring the lines between traditional broadcasting and online content. Today, media and infrastructure orchestration play a crucial role in delivering content to audiences around the globe. Technologies like cloud services, software-defined networking, artificial intelligence are transforming how media companies manage and deliver their content. But it's not just technology that's evolving. Media business models are also undergoing a transformation. Innovative revenue streams, subscription-based services are challenging the traditional advertising-based model in all phases of the production and distribution. So, what can we learn from this evolution? The key takeaway is that technology and business models are intrinsically linked. Media companies must be agile and adaptable to meet the changing demands of audience and the industry. In today's meeting, we will explore how media and infrastructure and orchestration can help to drive and support business models. We will hear from industry experts that work on innovative companies with very new technologies and his experience navigating this ever-changing landscape. Questions are always welcome. We have the Q&A session in Zoom open, and we are excited to hear from our presenters today. And now we are going to Marwan.
I think I'm on. So thanks, Silvino. Thanks, Noor, for organizing this. And let me proceed here. All right. So I'm here to talk about new paradigms of software architected broadcast facilities. I'm Marwan. I'm a product manager at Matrox Video. So let me start by covering a little bit about me. I started Matrox as an electrical engineer, bright-eyed, bushy-tailed. Went in the first day, got access to my powerful Windows 98 workstation. I got a flip phone. I got an analog oscilloscope because I was in hardware engineering at the time, and I got access to this really powerful clenchers that I used to compile software and compile FPGAs. And on my very first day, I also got this toolbox. Now, fast forward almost 24 years to the day. I'm using this laptop right now. I'm doing this presentation off of it. I'm using a smartphone. I do a lot of work in Amazon EC2 instances and use more waveform monitors when the time arises. And but up to this very day, I use that toolbox that I got, and I use it every single day. I used it maybe half an hour just before this presentation. I'm going to crack this open for you and show you what's in this toolbox. So this is my plumbing kit. And for the past 24 years, I've been working alongside a very talented group of people who have been developing plumbing for the broadcast industry. Now, specifically, plumbing in the sense of what is required for software to participate in broadcast. So let's dig a little bit into that discussion and see how that relates to why we are here today. So software, as far as I'm concerned, I'm sure all of you agree with me, is been sort of the cornerstone of the technology that's propelled the broadcast industry forward. So what is best of breed broadcast software? Well, it starts with a computer. This computer in and by itself doesn't actually do anything. What it has is usually it has an I/O interface that's specific to broadcast, whether this is SDI or 2110, and has sort of low-level processing libraries. And in the technology stack, I call this the middle layer or the plumbing. That's what makes a computer capable to participate in traditional broadcast infrastructure. Now, when we talk about broadcast, what we really, when we talk about software and broadcast, we usually think about applications. These applications are character generators, replay servers, production servers, PC-based switchers, and there's tons of them. Well, in reality, what these applications are, these are applications that a software developer with expertise in that domain has coded on top of sort of a middle stack that abstracts the complexity and the intricacies of what is required in broadcast, typically hardware infrastructure, to be able to participate in broadcast. And this is how we build content. This is how live production is done. This is how we've all watched and consumed media, specifically in live production, where this is used quite often. This is how we've consumed this as consumers. Now, one thing I want to note is that these applications have years and years of IP built into them, and they're monolithic. Now, that's in this day and age, that's used bit as a derogatory term, but that's just the nature of how the industry has pushed forward through the technology stack and how computers have gone faster and faster, and IT equipment has gone faster and faster. And we're going to see in the context of what we're talking about why this is important. Now, this is a slide I copy pasted, stole completely from my friend Michel Proux, where we co-presented at a SMPTE event in Montreal, and he described the evolution of live production infrastructure as going from the current generation, which he called Generation 1 and Generation 2, going from SDI to 2110, and going to what he called Generation 3, which is software-based and or cloud. Now, there are many reasons to be doing that. I think we're all listening to this or we're participating in this because we actually see that as potential, as giving great potential to our industry. Now, I'm not going to talk to you about fragmented audiences, about producing more with less, about personalizing and catering to what our customers are asking for. But the reality is we need to be doing significantly more productions and capabilities than what the technology stack of today allows us to do at significantly less cost, and that is a lot more automated. And if we look at the technology stack that we have, it doesn't actually give us that capability. But when we look at what the IT industry has done, what cloud computing provides, those look promising. They look like these are technologies that can be leveraged in broadcast to actually bring forth the innovation and what the market is demanding. So what does that look in terms of best of breed broadcast software? And once again, best of breed being allowing for the end customer to choose what they consider as being the right tool for the work that is required. So the computer is no longer a computer. The computer is no longer an appliance that's a black box that does a job. We're talking about EC2 instances, public cloud instances, or a stack of servers that's, let's say, call it a public data center, a private data center. Now, in an IT environment, there is no such thing as SDI or 2110. So we're missing that middle layer of the technology stack. And then we were discussing the applications and having a lot of IP being the cornerstone of how we produce today, how we produce video, live content today. Well, these applications are monolithic stacks that have dealt with sort of the broadcast infrastructure by talking to I/O interfaces, whether this is an SDI I/O interface or 2110 I/O interface, and they're not well suited to actually leverage the IT capability to its full potential. So if we take a holistic view, what are we trying to do here? If we look at what the goal is it's actually enabling tier one best of breed live production in software, because we always want choice. We don't want to be locked into a single vendor. At the same time, the challenge is we need to operate IT infrastructure like all other industries on this planet. We cannot use proprietary technology to produce what we're doing today. Now, what does that really look like? So let's dig a little bit deeper into that. So today, if you're a broadcast engineer, and many of you have a background in broadcast, we look at things as source and destination. A source starts with something, goes through different processing, blocks. These blocks are interconnected with an interface that's clocked, and that generates a frame of latency. So you go from one box to another box through SDI, for example, and that's one frame. You go to the next box, next box, and so on and so forth. Everything is lockstepped together and synchronized to a clock. If you want redundancy, we just replicate the same thing over again, and everything is locked together, and off you go. We have a synchronous clock-driven way of operating. Now, if you look at what other industries do, if you think of a source and a destination with processing blocks in between, well, you have processing blocks, you have VMs, you have fast networking interconnecting them. And what happens is one event triggers the next event, which triggers the next and the next and the next, and everything runs as fast as possible. So what we need to do is we need to somewhat change how we think about broadcast, which comes from a very physical, clock-driven mentality, to an event-driven asynchronous approach of doing this. So while we do all of that, one key item that we cannot lose focus on is we cannot compromise the broadcast principles. Our industry is built around a certain pedigree. When we tell the story, we tell it right, and we have requirements that have served us really well and have served our customers really well. So what are these requirements? Well, first and foremost, what we've built is we've built systems that are frame accurate. Built systems where at large scale we can control equipment, we can achieve frame accurate results where something happens exactly at the frame where we require it. We're able to roll a clip, insert a bug, get live for a very specific frame and have that happen at large scale. So we've built those capabilities, and it's in a non-trivial way, but we have that capability today. We have low latency systems because when we tell a story, we want to tell it in live production, that we want to be the first to tell that story. We've also built responsive systems where operators are able to perform an action and see the feedback right away and actually act on it and be sort of produce it live and be part of the show through their choice of actions. We've gone to a lot of trouble to engineer redundancy and have no single packet dropped, no pixel is better than another, and really maintain a level of excellence and redundancy in our systems. And we've built the capability through huge routers to create clean switching capability at large, at scale, and be able to have many inputs, whether they're live or clips or whatever it's coming from, to clean switch into a production. And something that's really important is we've built systems that are observable. So during operations, we're able to drill down into a problem, into where a potential problem may happen and maintain those. So we've have sort of a way to operationally control what we're doing. So all of this I'm calling next generation plumbing. And that's the ability to enable tier one best of breed live production and software, doing this all using standard IT infrastructure, nothing specific to our industry, nothing specific to broadcast, and to do that at scale. And this is what led us at Matrox to introduce a framework that allows that capability. So let me dig into a little bit how such a framework can operate. So let's look at how live data can be processed. So we can start with glass, and that's a real-time source. So we start with a camera that's a real-time source that comes in at a certain cadence, and a monitor expects to see real-time data at a certain cadence. So what we have is we have a system where real-time data comes into an asynchronous processing blob, frames or grains get numbered, and this numbering system relates to real time, and this real time is actually tied to an eventual presentation time. Now, these are real-time constraints on such a system, but control is also a real-time constraint, because when we're controlling something, when we're controlling in today's world, we're controlling time, and time associates control to data. Whereas in an asynchronous environment, you don't really know when something happens. You don't really care. All you care is that it's ready before it's needed. So control, it places a real-time constraint and actually targets frames, no longer targets time. So let's look at what a journey to complete software looks like. Let's start at the public cloud, the hardware level. Public cloud, these are EC2 instances, CPUs, GPUs, fast networking, or on-premises data center with professional I/O interfaces, let's say SDI or 2110. Now, what we need on top of this is a media-aware framework that brings scalability, brings resilience, has built-in timing, and takes care of the flow of data across systems. This is what we call the asynchronous media framework. Now, this framework doesn't actually do anything by itself. What it requires are media services, and media services are the pieces of software that actually do work. Now, there's the type that interfaces with the real-time world. Those are the I/O services, whether they're software-based, like an NDI, a CDI, SRT, so on and so forth, or the hardware type, like an SDI or 2110. Other than that, the other media services, we could think of them as specialized pieces of software that process grains or buffers or frames of data. This could be audio, it could be ancillary data. A good example would be a video mixer, an audio mixer, audio shuffler, these types of processing. Now, in order to have a best of breed or to allow for choice, what we need are APIs to allow for vendors who are specialized in that domain to build these media services. Now, when we talk about systems that reside in the public cloud or in a private data center, well, what we need is a control application and we need a control application that's decoupled from the actual hardware. And what we believe is web APIs is actually the way to go, because that's the natural way of doing this. Now, control application is there to provision and control media services to actually perform a task. Now, to complete the picture, if we're thinking about large scale or big scale deployments, what we need to think about is orchestration and monitoring. How do you deploy these systems? How do you monitor that systems are working well? What this image requires is metrics that would allow for somebody to measure what's happening and automate this whole system. Now, all of this is parts of the Origin framework, and it's our vision of how to enable software infrastructures, whether it's on-prem or in the cloud. Now, if we look at it from a system architecture perspective, I was talking about control applications. Now, control applications it could be one, could be many, that talk to a web interface. This web interface talks to a server. Now, this server entity maintains the state of all the systems. It's backed by a database that contains the state of the whole systems. Now, to continue that flow, what we have to actually do the work is we have hosts. So these are, for example, EC2 instances or Dell servers. And on these hosts, these computers, what we have are media services that perform work, whether they're the ones that interface with the real-time world, or whether they're do a specialized job like video mixing, audio mixing, or audio shuffling. And these services, to actually perform a task, are interconnected with a transfer fabric. And this transfer fabric can be thought of in its simplest form as a media database. This media database is built using shared memory and high-speed networking, but what this media database does is it abstracts where content resides. So a service can write a frame with an ID, and another service reads a frame with an ID, and it blocks until it receives the frame that it requires. And once it gets that, it runs as fast as it can and dumps its own content into the frame. It doesn't maintain any state. It just runs as fast as it can. So why am I telling you all this? What's so great about such a distributed architecture? Well, I'm going to talk about scalability of a system like this. So in this architecture, what you could see is you can add as many hosts as is required. Media services can actively be spawned on these new hosts or current hosts. Media services can be migrated across these hosts to sort of create the capability to shrink or expand computational needs to meet dynamic operational needs. So if you think about, let's say, a GPU instance and trying to match GPU, Windows instance are the most expensive that you could use. So if you're able to fold that into your because there's a operational need to do so. If you're able to fold that into your infrastructure, use it, migrate services onto it, then once it's done, migrate the other services that have no dependency on GPU back to other hosts and shut it down, then you can really track your costs and really use only what you require. From a reliability perspective, this architecture gives you smart redundancy where everything is protected at frame level. So when we're talking traditionally, we're talking about streams of data, but like any software developer, what they actually care about are frames or grains of data. Streams are not that useful to a software application. So in this environment, we deal with frames. And an application can choose the level of redundancy that it requires simply by deciding where a media service runs and how many media services run. And you can build sophisticated redundancy schemes where there is no single point failure across availability zones. Now, in terms of agility, you can configure everything with the granularity of a frame. So we can essentially build non-blocking routing at the fabric level where any frame can be routed anywhere. Now, one thing I really like to highlight, and it's nuanced a little bit, is that when we talk about distributed systems, what we're actually talking about, and it's nuanced, is that everything is built around media services. So what we typically call an application today is no longer a traditional application. What it is, it's actually control of many media services that perform a task. And this is in contrast to an application itself performing the task. So the implications of a distributed environment is that we can build solutions that scale beyond the capacity of one single compute instance. So for example, if you were building a vision mixer with 10 inputs, 20 inputs, or 100 inputs, it doesn't really matter. You can expand capacity beyond one capability of one single host. Now, one key item to also talk about is latency of architectures, of distributed architectures. And in this case, we're talking about event-driven architectures. So these run as fast as possible. So if we're to contrast that with a traditional approach of doing this, where let's say you have 5 cascaded mixers, well, just connecting from one mixer to the next mixer costs us a frame of connectivity plus the additional processing time of mixer. So in this example here, where we have 3 frames per mixer, that'll bring us up to 12 frames in 2 out. Now, if we look at an asynchronous processing pipeline, well, things run as fast as they can, as soon as they can, and one event triggers the next, and things run at a fraction of the speed of what we traditionally expect to do. Now, just for fun, I ran some metrics on a system that had 5 cascaded mixers, and this is in a 1080i 50 configuration, and the latency of the system is set to 5 frames or 10 fields, and the mixers are actually in different availability zones. And what you can see from the metrics in the system that here the network is showing uncompressed data being transported across the network. And what you can see is, well, with our configuration, when we're working asynchronously with a pre-roll of 5 frames, what we see is that our main output, which happens to be WebRTC right now, is actually completing its task within less than a field of time to perform all that. And the rest of the time of the pre-roll is just additional buffering. So I have a whole presentation about asynchronous processing versus synchronous and what that implies. It's a whole other 45 minutes, so I will not go into that. But if you're interested, please reach out and we can talk some more about that. But what we can see is asynchronous processing that is time aware actually really brings a lot of benefits on the latency side as well. Now, I'm just going to end this real quick over here. When we set out to solve this problem, we're looking at software infrastructure because we're looking at transitioning to cloud solutions, but in reality, it makes what we do on-prem today a lot better. Now, the key item also is that this is a complete software transformation of our industry, and that creates lots of opportunities for everybody. So, from end user media producer perspective, can create a lot more content with a lot less infrastructure. You can use the advances of the IT industry to your benefit. It requires a lot more customization in order to achieve that, and that creates opportunities for system integrators and the likes of it. It also adds opportunities to software developers that can unlock capability by sort of adapting to this new reality and working in systems that are built for software infrastructure, for cloud infrastructure. So really exciting times. So we've been talking about these concepts since NAB 2023, and at the beginning it seemed a little bit foreign and alien to some people, but with time we've been receiving overwhelmingly positive feedback from the industry, and there are a lot of partners that we're interacting with, we're dealing with, to talk about new workflows that were not possible before that are now possible when using this new way of thinking or solving the same problem. So if you're interested to get involved in this, please feel free to reach out. I'm happy to talk about this ad nauseum, actually. So with that, I'll pass it back to Noor.
All right, Marwan, thank you so much. Before we switch, there's a quick question for you.
Sure.
And by the way, I do see some questions coming in for Karen, and we'll look back and discuss those towards the end. But for you, Marwan, what kind of production you envision could take advantage of Matrix Origin?
That's a really good question. Now, when we're working with customers who are working on what they're calling stream augmentation. So we're working from on workflows to produce content that would have never been produced because just producing it was just too cost prohibitive. It required CapEx, upfront planning, required a lot of operators, lot bigger budget. So we're working with people who are looking to create content with let's say a single commentator / operator, because the content that's being produced doesn't warrant having a full technical staff to operate equipment. So we're working from that level all the way up to tier 1, where people are looking to have 40 1080p 60 streams being processed. So our position is the infrastructure. If you think about how SDI has serviced our industry, we never really said that, or SDI never really said that you couldn't produce something because it was too low. It was sort of tier 3 or tier 4. SDI worked in tier 1, same as it worked for tier 3 and tier 4. So our vision for the future is to create sort of an infrastructure that allows the gamut of low end all the way up to high end content. So I don't know if that covers it, because I'm basically saying a bit of everything.
Sure. Yeah, that's fair enough. And I encourage folks to drop questions in the chat. We would love to get to them as well towards the end. So please keep the conversations coming. And so thank you so much, Marwan, for diving into Matrix Origin. And now Vinicius Calera, who is the Senior Director of Consulting and Innovation at Formula Monks, a globally recognized firm under Media Monks, will take us on a journey to new monetization models. So Vinicius, over to you.
Thank you, Noor. Hi, everyone. Nice to be here. So thank you for the introduction. Thank you for being here. very excited about, having this conversation, and, very similarities of Marwan and Karen also mentioned about the cloud broadcasting and the software defined. So very quickly here, what's MediaMonks? MediaMonks is a global consulting firm, and we have this verge of systems integrator within broadcasting. We have this transformation consultancies, we have cloud architects, and we have managed services, and been working with many broadcasters around the world. Also, we are partners and integrators and orchestrators of many of the next generation technologies. So we're talking about NVIDIA, AWS, Vertex, Google, Adobe, and many others within the broadcasting ecosystem. And also been working with many companies here around the globe. So what I would like to talk about is how we can take this approach from camera to consumer, and how we start from this live cloud and media supply chain production, and start moving forward into the processes to produce personalized content, and on top of that, monetize. So what we are seeing in the industry, our vision here is that as my colleagues mentioned here, media production is changing here. So we're not talking about people watching live videos, but people watching different types of videos. So when we're talking about Gen Z, some stats here, they are spending 15% more time watching highlights in sports than live games, for example. So they are also using 89% of Gen Zs use second screens while watching TV. They are twice likely to never watch TV but stream sports than other generations. 59% of Gen Z use short form videos to discover long-term content. So as my colleagues mentioned here, the highlights and the cuts. And also almost 40% of Gen Zs never watch live broadcasters in their entirety. So we are changing this industry. So for us right now, the content lives in a 3D ecosystem. So we are not just talking about broadcasting into one channel, but multiple channels, and the content has to live in different systems and different channels here. So right now, the role of the broadcaster is not just about broadcasting and having the best signal. It's about having the best content pipe that's interactive, that's fit for any format, that's remixable, and that has it's adaptable for any part of the ecosystem that we're talking. So in our point of view, the best pipeline wins. So we have to deliver, and we have to change that whole ecosystem. And it all starts for us, how do we monetize this attention? So we live in this attention era. So we know that money follows attention. So if attention is going towards different channels, different formats, we need to start thinking about how to feed the feeds. And also we feed the feeds with all contents and different types of formats. We need to start thinking about new monetization models and how we can take advantage. So this is how we are seeing this whole scenario. And the first step that we take when we are in a journey of transformation of any broadcaster is to become a software-defined broadcaster. So in other words, it's like moving from Cooper to cloud, and has a lot of impact when we're talking about this full journey, camera to consumer journey. So we're talking about having a more flexible stack that can produce this 3D content with that can be delivered from many channels, and it has also a lower cost. So here when we're moving to the cloud, we can have not only the cost impact, but revenue impact when we're talking about agility, ability to deliver all formats. There's no startup initial cost when we're changing the production. And also there has a lot of governance impact, like redundancy, flexibility. It has a lot of sustainability. So this is the biggest transformation that we're seeing in the industry. So what we're doing basically is moving from Cooper to cloud. So using a lot of our cloud providers. So AWS is a very good partner of us. And we work across different partners as well. So when we're taking this transformation, what we are looking for is something similar to what we did for NBA, for instance. So we did that in the middle of the pandemic. So what we did, we produced all the content NBA, and then we are in our third season in a row that we are producing as we were in the seats and the side seats within NBA, and we are streaming that in 8K for Meta VR glasses. So we are, shifting the attention. We saw the trend that the attention is moving to different types of content for us to engage with, younger generations here in the NBA. So we are streaming that, and everything is running in the cloud, in multiple ways. So we are operating with Brazilian team, a team in the US, and a team in the UK, operating simultaneously all the games in the season. Also, we did, a big transformation with a UK broadcaster, ITV. So we moved from the cloud broadcasting, and this is, a photo that we took from a control room here that was, built within MediaMonk's offices that is 8 miles away from ITV current site operation. So we did that. There's a big cost reduction here, and we proved that's, feasible for us to run the same show with the same quality and with lower cost and moving everything to the cloud. So this is the first step. Once we do that, as Karen, for example, was mentioned, we can transform and start to, applying technology on top of all the feeds that we have. And then we can transform every single pixel into a new IP space. So this is what we built on top of NVIDIA technology and HoloScan, so that we can take, for example, one, game from a volleyball, and then we can have an audience that we know that is, very into sneakers, and then we can, just target, for example, this as an IP, and then we can cut the speed and, put on social media. So we are applying this new, top of technology on top of the cloud that we're building in order for us to have real-time highlight speeds that are cut down throughout the system. And once we do that, the idea that we have is every channel can be an opportunity for us to drive this audience engagement. So we know the audiences engage in different systems. So the idea here is for us to start understanding those audiences and, almost in real time, have these highlights. So this is something that a case that we did with UEFA Champions League and Adidas, for us to engage during the live show, during the finals of the UEFA Champions League in the soccer event, that we took, for example, the trend that Gen Zs are watching live sports within a second stream, and then we use AI in order for us to take what was happening during the game and, have people have conversational chatbot within Del Piero's voice. Del Piero is a very famous soccer player. And we did that for launching Atlanta, a TV show, and then also for John Wick. So that we use different channels here for us to expand and took the part of the feeds that we are having already in the cloud, already in the archives, and using AI in order for us to, deploy that for different channels. And this is something that we run, for example, with Post Malone. When we're looking at audiences, we're not looking into something static and something that's like, one thing. We're looking at audiences is the interaction of different interests. So this is an analysis that we did, a visual analysis that we did with a partner of us for Post Malone, a live show that we did here. And basically we can see that, the audiences have different interests. So the idea is for us, how do we engage with a Post Malone audience and fan, but is using to US sports or to music and culture or into rock? So we need to have different feeds and ways to engage these people in order for us to maintain viewership, and viewership we know that drives my attention, and then attention drives money. So after that, once we define and we have the best content pipeline and understanding our audiences, what matters for us to define the best channels. So this is where we apply our media mix modeling tool that's powered by AI. That what we use here is to understand what are the levers and the factors that can impact more or less our main KPI. And we're talking about KPIs here. I'm talking about viewership, subscription, monetization, and any other business KPIs that we have. So we have here a forecaster that we can play around and use many simulation scenarios for us. Also, we can play around with some variables here and everything is connected to a RAG, so people can also talk and make business questions in order for them to gain insights about what's happening, how should I engage, what's my media plan, and what are the channels that I should engage, what are the content that I should put more focuses on, or less. And this is what we built with ITV. So this is what we are building. For example, how do I grow my audiences? What are the channels that are performing more or less? So we have all this information, all powered by AI. And then we understand how we can deploy best each one of the contents based on some data insights. And then last but not least, once we have all a live stream a live production that can be deployed for many formats. We have a production pipeline that we have content, and then we have the channels definition. We can start building monetization, and then we are seeing 6 great business models. So we are seeing that companies are doing community rewarded ads. So people are using rewarded ads in order for them to go from free business models into subscription business model, but also monetizing and rewarding the engagement of the community. We are seeing live highlights and sponsorships. So imagine that we can take one sport game from an NBA, cut down to a highlight, and have a sponsorship from one of the sports brands. So we can make money out of it. We are also seeing a trend, especially in Gen Zs, there are microtransactions. So people are more likely to spend the same amount of money, but broken down into different buckets instead of having, all the same amount into one single purchase. So we need to start thinking about how we break down our services, our business model into different features and different formats, and how do we bundle those together in order for us to have this microtransactions in order for us to keep engaging and converting. The fourth one is virtual product placement. So for us to use Gen AI, for us to change, for example, a brand from Coca-Cola or a Pepsi or a Budweiser beer can, so we can play around using virtual placement that is fit for format. For me, for example, if I'm a Coca-Cola fan, I don't want to see Pepsi, I'm most likely to see Coca-Cola. So we can use that, and there are many broadcasters that are already using this. Also, once we have everything in the cloud, as Karen, for example, was mentioning, we have contextual targeting, we have much more data, and then we can use a lot of data simulations and segmentations for us to have more contextual targeting and improve our current business models. And then we have, also applying, for example, AWS, we can have integrated shoppable experiences that is integrated within our feeds and our live shows. So to summarize here, there are 4 main steps that we are taking our broadcasters and our partners into this transformation. The first one is to have this, as I mentioned, software-defined operation, so you can have flexibility for deploying any type of content. We have lower costs, and then we have a better governance. We have this 3D content pipeline powered by AI, and how we deploy that using AI, and then helping us in the production and post-production. We have this viewership measurement optimization for us to make data-driven decision where we should put all the content that we are producing, because right now it exploded to different, not just one format but many. So we need to have this data-driven decision. And last but not least, we need to apply a test and apply different monetization models that we highlighted here, 6, but there are many others that we are seeing in the market. But for each one of the channels, the audiences, we need to fit and find this matrix of adherence for each one of the business models. And that was it. So happy to keep this conversation. Reach out to me. Here's my email, my LinkedIn as well. So feel free to contact me, and happy to continue the discussion. So I'll pass it over to Nora.
Thank you, Vinicius. That was really, really interesting. I do see one question for you. How much work is involved in preparing all these audience profiling and models, and how it impacts the modus operandi of a cable to channel?
Sorry, can you hear me? I'm muted.
Yes.
Okay.
Can you
So
hear me?
Yeah, of course. So I thought I was muted, sorry. So we can start small. So always is a great question, but like we can start small in order for us to understand the audiences, work with your first party data, but also bring a lot of third party data for us to start measuring. So when we're having a linear broadcasting, we can start building, an interactive model like we did, for example, for Del Piero and Adidas. And then we start collecting other types of data that's, our audiences, but through a different interactive model, we start getting data. So one action feeds the other. So we can have this content type, having more interactive content if we don't have this user ID and this first party data, in order for us to start collecting data and start building this strategy. But also we can use data from media activation, for example, and how people are engaging with our ads in order for us to build this first cluster. So we can start. We need to understand, however, it's built on top of your stack, what are the information that you have, and there are many ways and levers that we can play around. Very first to start building, and it's a constant thing that we should always keep building the data and understanding our audiences.
So that makes a lot of sense. So essentially start with lowest hanging fruit, always focus on the data, start with workflows that have immediate impact, and then grow from there. Is that a fair summary?
Yeah, exactly.
Awesome. Well, thank you so much for that, Vinicius. And then we encourage folks to continue to pop in questions in the chat. We'd love to get to them either now or later. So now to our next presenter on intelligent orchestration, Stephen Southern. Stephen Southern is the Director of Innovation Development at Diversified, and we're so happy to have you here, Stephen, and so over to you.
I certainly appreciate the opportunity to just talk with everybody this evening. So I'm going to intentionally kind of stay away from the topic of AI because I don't know that I can add any more to it. There's a lot that's been said and a lot that's going on, but I can talk about it if you like. As our industry moves ever closer to cloud-based tools and products, we find ourselves in an exciting time where experimentation and exploration are more accessible than ever. Virtualized environments allow us to build complete production environments to test and validate functionality and business cases without fear of locking in investment dollars. We don't have to build a physical facility in order to do production. So we've seen greater requests for POC as a service, as well as a willingness from end users to be more aggressive in pushing the boundaries of what's possible. Some of you might have even been involved in a recent POC that we did for a major broadcaster in the US to see if NDI would be sufficient for their local TV station production. So it's truly incredible. We've come such a long way in the time that I've been in this industry, and it's really awesome to see. So unfortunately, we've seen with this newfound flexibility and increased complexity that actually acts as a barrier of entry for some. So to fully leverage all that any cloud environment can offer, an enormous technical understanding is required. Traditional broadcasters have to hire a greater range of technical subject matter experts, not just video, audio, transmission, but also network, database, security, cloud certified architects. From a systems integration perspective, the range of services that we must provide is also expanded. The landscape has shifted significantly, and most users are expecting something that is capable, yet intuitive and simple to use. Broadcasters are embracing the newfound freedom of exploration, yet may be hampered by a lack of understanding the technical nuances of the cloud. What we've been working toward is a way to free our clients' production teams. What we envision is a way to abstract away the necessary engineering expertise and focus on automated orchestration of cloud resources. Think about it like driving a car. You want to open the door, sit down, turn the key, and just drive. That's kind of what we're shooting for. So we come up with this concept of user-led orchestration. So we believe that decentralized production should just be that easy. So if you're familiar with the concept of infrastructure as code, you can begin to see the potential of automating not just the environments themselves, but applications. Products like Terraform, Ansible, OpenTofu, they give us a way to script entire environments like networking, compute, storage, but also applications so that an end user doesn't need to be a certified guru in a particular environment. AWS really nailed this with CloudFormation. So from an engineering perspective, this is not a small task. Simplifying complex tasks is hard. Those of you that are familiar with computer programming know that to accomplish the most menial task requires more steps than you probably ever thought of. So for example, you might spend a significant amount of time doing the initial configuration, but with IAC, each subsequent deployment takes magnitudes less time. So once you have an environment script that works for your production, you can begin to modify, to iterate on it. Now you can experiment with it. If you have an idea that you want to try out and you're free to do that, go ahead. If it doesn't work, you can fall back to your last known good script. This process is not only automatable, but it's repeatable. It can run in parallel to speed up deployment time. It can be set up in a modular fashion. So this is key. The modular piece of it is something that shouldn't be overlooked. So modular building blocks, like say a video switcher, made by one vendor or another, can be deployed independently of a larger system. If you deploy a particular product and you monitor how much you use that product, you could theoretically only pay for the time you've used that product. With adequate logging and telemetry, you could, over time, estimate how much a production should cost based on the tools that you've selected. And this is huge. You can determine if it's worth the OpEx investment based on the cost before you actually incur it. So this opens up your total addressable market, provides one-off opportunities that you may have otherwise missed or overlooked. Some end users, like houses of worship or high schools, could experiment with production tools that were previously out of their reach. What if the local PBS station provided support to the neighborhood high schools, helping to bring greater local viewership to events on their channels or sub-channels? So your workflow could be as simple as logging in and then being presented with a number of templates that are a collection of scripts on the back end. Once you select a template, you can make configuration modifications if need be, say the number of video sources, audio sources, etc. Then deploy that configuration immediately or at a point in the future that you've scheduled. So with a decentralized production team, each person can be located wherever they need to be, and they aren't limited to a physical presence. They can work on an East Coast basketball game and then move to a West Coast pregame show the same day, all while avoiding the TSA. Once production is finished, the entire process can be stopped and the usage of the components is halted. Now, this is still in the innovation stage, but our preliminary work with the vendor partners tells us that the interest is there. Every partner has a plan that includes cloud, and we're absolutely moving towards software as the future of pretty much everything. Building tools and products in microservices architecture that can spin up, scale, and spin down as needed helps us realize the true value of the cloud. So honestly, a lift and a shift of products is missing out on the scale and flexibility, which could ultimately provide the industry with a true consumption-based model. Microservices, while not perfect, do allow for some advantages in our dev environments. They provide the ability to be scalable, fault isolation, improved resilience, faster development, faster deployment. So in our own development group, I can have multiple team members working on different aspects and test them independently and deploy them without taking down an entire application. As product APIs become more mature and robust, even greater flexibility is going to be available. Access into configuration parameters could allow tighter integration and perhaps contract TD could take his or her own profile to multiple productions between providers or employers. A login or a scan of a badge could load that profile up once they log in. So again, I want to reiterate that these are innovative ideas that are still in development, but we feel that with the partnership of all the folks like those of you on this call, this is what could be possible. So we believe that this is where the industry is heading, and people really want to innovate. We've heard this throughout the other presentations, that innovation is going to be a key to the future of what we're doing here in broadcast. So if there are, I appreciate the opportunity to be able to talk with you all this evening, and look forward to any questions or thoughts that you all might have. And if there's anything that I can do, please reach out. Feel free to contact us.
Stephen, thank you so much for that. There is a question for you.
Sure.
So considering you need a new set of skills, people, that is, plus a cloud/data center infrastructure to deploy infra as a code, in your vision, where is the break even for production? Is there a minimum size to tackle this new environments?
Well, that's an interesting thought, because what we're hoping to see as our vendor partners continue to evolve their licensing is that, you know, the idea that we've been told that if you move to the cloud, you're only going to pay for what you use. So if you can break down not only your compute costs by the hour or by the minute, if you could do the same thing with any software product like a video switcher, an audio mixer, where you're only paying by the hour, I'm hopeful that what we'll see is a number of end users that ordinarily wouldn't have been able to be able to access those professional production tools, be able to do that, so that you're spending, I don't know, $200, $300, $400 for a 2-hour production, maybe less. It just depends on how flexible our vendors can be with licensing. Hope that answers the question.
So it sounds like there's much contingency on granularity of licenses and how flexible they are to allow kind of all sorts of tiers and samples of
Yes, ma'am.
workforce.
That's right.
That does make sense. Stephen, thank you so much. And again, folks, please do keep the questions coming. These are really interesting discussion points. And now with our last but not least presenter for this evening, Roger Bitos, who is a director at Skyline Communications. And Roger will talk to us about the Media Factory and Media Ops as a new frontier of broadcast as a service. Roger, over to you.
Thank you so much. Good evening, everyone. Thanks for putting this together for the SMPTE group. Glad to be here. Can you all see my screen?
Yes.
Thank you. So that puts me, being the last one, puts me in a very awkward position. I'm the last one standing between all the information and the wrap up. So I'll try to do that. Please keep the questions coming, but I'll try to do that keeping in mind it's 8:30. So let's talk about the Media Factory. What do we consider to be Media Factory, and how does that change the world that we live in? From a very practical perspective, we come from a place where we had we would buy a technology, we engineered a technology, and the technology was going to be there based on a or a few business models, and that was predictable for a number of years. Everything that we heard so far, it's about the agility, the flexibility that IP comes in, about new ways to ingest, share the content, the content that they produce. So this is what we within Skyline we call the expect the unexpected. And what is that? You know, you no longer buy an IP network, right? You buy the capability of providing services is in there. So moving forward, the complexity as well as the scalability goes hand in hand. And what we're here for, like most of the colleagues in here, to lower those barriers of adoption. So in that case, data miner, what we consider is a framework that we consider it to be an enabling framework, right? And how is that achievable? Though being a framework is all about leveraging the best of the APIs, the best of the community. You have a robust community. We do provide the software development kits, co-repository to do exactly what the colleagues have said. You know, now you can you no longer need to go for that huge CapEx investment. You can have those virtualized environments that you can test, trial, and proven what you need to, what you need to spin in order to have that broadcast as a service. All right, and from a media perspective, way too fast. From a media perspective, all that means is the ITLization of our industry. Okay, we come from putting boxes together. I think Marwan got the example of having those the 5 mixers, and in order to, hey, I need an environment, I need to spin that environment. I can do that with AWS. I need an EC2, and I can containerize that, and I can load the application. Now I need to configure and I need to orchestrate my multiple applications. This is where the merge of the IT, the ICT philosophy comes in with the media, because yes, we still need to provide frame accuracy. We need to insert content. We need to get that data for the other companies that have exposed to be able to do the in the analytics on the ad, and so on and so forth. So all that relates to on the multiple stages that we go through. All right, but before we go to the stages, the trick of the trade is to be able to build that digital twin. The digital twin, once you spin the environment, and now you have your microservices, and that microservices, you're going to have your applications, and within your applications, you're going to provide a certain function that you can build your workflow together. Those are, we consider, the digital twin. So you have to have a robust data collection in order to build that digital twin, and that digital twin is going to produce a certain amount of functions and functionalities with capability and metadata in order to build your workflows. All right. And then there's the data consumption on top of that. So all that powered by machine learning and AI. So within the framework, what we do offer is the capability for you to build your own digital twin. We have over 8,000 of those connectors, if you will, in our catalog. That breaks down into those virtual functions. If I need an encoding, if I need a muxing, if I need a if I need to marry that to an SDN controller, if I'm going to in an environment, if I'm going to get a new device in there that has to go to the registry and to be able to broadcast itself, here I am a camera, and I have this source IP with this multicast IP, and built that on the 2110, and having those virtual groups that now you don't need to track each and every one of the separate IPs. You can track the virtual group functions of all the multicast IPs that composes that service. So we do have all those pre-built, let's say, applications, but those are sample applications. And why sample? Because this is the marriage of technology, people, and processes. All right, so the IT world, we can come in with your Terraforms, your Ansibles, and we know when something needs to be available. That something can be on the ground, on the cloud, can be a permanent resource, or it can be a resource that is licensed and consumed as needed. And moving forward, how does that translates into the workflow? and to the workflow of the orchestration, if you will, right? It always starts with having the inventory. The inventory can be physical, or the inventory can be an inventory of licenses, or it can be an inventory of costs that you have in order to spin the environments that you need to spin and scale. You might have an ingest that comes from an antenna. There's no way to virtualize the RF, but everything else you can. So above and beyond that, there's the planning phase. And that planning phase is, what do I need where, and what metadata do I need to plug in there? All right, and that metadata might be location aware, it might be contracts, it might be people, it might be trucks, it might be all sorts of things that, in order to spin that environment and build a service model in that environment, provide that environment, and then you need to do the reservation, the approvals, because the workflow is the workflow, it hasn't changed. If I need to provide an entire season of sports, doesn't matter what the nature of the sports is, you need to know what kind of resources you need to dedicate for each and every one of those events. Those resources might be physical, might be virtual, or might be on demand. And that's the beauty, that's the scalability, that's the control plane and the orchestration layer that can be fully taken advantage of. Now, the part of deploy, configure, connect, control, monitor, and all that, this has been what the framework has been known for many, many years. And by the way, this doesn't have to be in the same framework. It can be just, hey, I know I have a reservation and I need to go in and ask for the group X to spin the YAML that is going to give me the ECS or the environment, the EC2. And then I get the 200 OK. I move on to load, for example, a GVAMP environment or an RTS intercom, which is totally cloud-based. And all that is, there's this dynamic. Do I need to extend? Do I need to move resources? Whenever I finish, I need to tear down and leave those licenses available for another service, and or if it is a physical resource, free up that resource so it can be used for another event. So this is maximizing their resources and automating the process at the same time. And once you finish, all that needs to be sent to the costing, billing, advertisement, and all that, right? And how that is done from a very practical perspective. All right. In the environment, we do have, so I'm just going to talk through a couple of those. In this particular case is just a data miner going in, spinning the resource, in this case, AWS, loading up a Grass Valley environment and loading up an RTS intercom. And at the end, doing the cross points, loading up the multi-viewer, and at the end, releasing those resources. It's just to append to that within that process, and we don't have time to go through that. By the way, all that is available in our community. You guys are more than welcome to check it out. But there are functionalities of declaring those resources, using the resource optimization according to how much you use, as well as how much there's the costing and there's this billing, right? Because the cost is what cost you. The bill, it might depends on whom you're gonna provide that. It might have different contracts, if you will. Your contract might be by resource use, your contract might be by event. All those flexibility are built into those applications. And here's a very interesting one, because this is about just training language models in which you can have your examples that you can share with your customers in a portal. Hey, if you need to reserve a service with us, right? Here is the format in which the ChatGPT already knows how to transform that into a JSON, which is going to automatically create a reservation in here. Now, a reservation needs to go through the process, whatever process you have, by the way, of transforming that reservation into an action for you. But fundamentally, those slides just illustrates the following. Regardless if you ingest that from a scheduler on the cloud through a portal, or you do that on an ad hoc fashion. Okay, I'm gonna just schedule something to take place right here, right now. All right. You can enter the minimum amount of data, or you can enter the metadata that is necessary. That is all driven by your business model, and that's it. As the software adapting to your necessities, not the other way around. All right. In this particular case, I have reserved something to occur here, and that something is going to tell me that the environment has been successfully spun up, the license has been successfully loaded, and the workflow, the automation itself has also been accepted. So now in this pre-roll, you can go ahead, the user can go ahead and see all the schedule, the ad hocs. Someone goes into the SDN, do a cross point on the matrix, you're going to be able to see those resources being utilized, so you don't have conflicts, you don't knock out things off the air. Having said that, you can still have your dashboards in the environment, but it is also built in the capability to look at the technology provider GUI. In this case, is the Grass Valley GUI. And you can see the cross points being made, or you can see, because a lot of times this is about the adoption. This is about making it easy for the user to adopt without having to retrain an entire workforce. All right. So once that takes place, yes, there is the tear down of all those resources. And how does that plays around? So I have it here. I know something is going to happen. My services are stopped. This is already ready to go. And if I go in, it gets closed because I don't want to pay for those for that environment or for that license more than I use. And then now it's pending. In other words, it's in the process of check, making sure that everything is ready to go. Once it starts, you can clearly see what are the resources that are being used for that specific one. Everything is running. If you can absolutely check how much you're using, how much has been utilized, go back to the resource optimization and see that by customer, by month, by whatever is needed. And at the end, when it goes as completed, it just goes, stops, releases everything, so you don't leave things running in there. So I took my 15 to 20 minutes, and I think I'm going to stop here. And not that I want to, but questions are welcome.
Thank you so much, Roger, for that. I will probably be reaching out to you. I have a lot of questions, and this is definitely very interesting. There had been some good chat happening. I see a question for you. Based on your experience, when your clients migrated for quote unquote managed workflows, what are the advantages?
Well, the advantage is the following. the tasks that are extremely repetitive has an extremely high rate of cost reduction, cost in errors, resources, lack of resources, conflicts, and so on and so forth. But the reality is, you still have those ad hocs, and depending on how they are recurrent, it reaches a point of being counterproductive. If you have some sort of services that you're going to run, 4 or 10 times a year, you're much better off doing the way you do it. All right. So there are, because again, I'm going to go back to the to the slide. This resides on technology, people, and processes. All right. So again, if you're going to if you start migrating on that, you got to go to the 80-20 rule, right? The low-hanging fruit. What it is, the most repetitive tasks that takes the most amount of man hours and is prone to the most amount of errors? Or do you dedicate some resources to do certain types of services, which is very, very common. Our customers that does a large broadcasters does, especially in outside the U.S. that do soccer, for example. That is only used, that environment is only used twice a week. So now they have the confidence that they can reuse that, because those resources can be used for something else without the risk of losing configuration, without the risk of being a double booked, things like that. Does that answer?
I believe it does. And
Okay.
for any follow-up questions for Roger, please do use the chat here. And, with that, actually, this concludes our speakers for the evening. All right. If any more questions arise, please pop them in the chat. Over to you, Tony.
Thank you, Nora. So let me see if I can get this to move forward. There we go. So I just wanted to take a couple of minutes and promote our TTC, the Toronto Technical Conference, which is going to happen next month, June 11th and 12th. It is when media and AI meet. We innovate, adapt, transform, and generate. As mentioned, June 11 and 12, we are looking at three, over the course of the day, three segments: fundamentals, R&D of AI, responsible AI, and impacts of to the media. And it is a day and an evening. June the 11th, the evening of, we're going to have a barbecue event, which will start around 5:30. We will have a keynote speaker and our section meeting. And the formal meeting will start at 7. As to the keynote speaker, we are looking at, and yet to be confirmed, Bernard Jenkins, who is the SMPTE president, to speak to us about that. And then he will be part of, again, we're working on this, he will be part of a panel discussion the following day. June the 12th, registration will continue and open at 8 o'clock in the morning. We start a full day session starting at 8:30. There will be a trade a showcase where manufacturers will come in, set up a table and show their wares as to whether it is AI related or just something new that they want to show to the audience. There will be a wrap-up networking event at the end of the day, and we all get to go home at 7 o'clock or thereabouts. There is a QR code that will take you to the TTC website where you can get all this information. We will constantly be updating that for presentations who we get locked into the presentation schedule. Again, registration is open. An email blast went out this morning, and it is at the CERT stage 10 at the Pinewood Studios in Toronto. And here's some more bits of information where you can find things, call for papers. I think there's still a few slots available. The TTC 2024 website is there. And if you want to get involved and help, do reach out. And I think, oh yeah, just to help promote our partners in Canada, the Montreal section is having their boot camp, which is also on AI. It seems to be a popular topic. Even at NAB, it was all over the place. So they are on May 29th. And I think, Lawrence, that is it. So I can change the slides if you want to speak over the slides, or if you want to steal the show presentation, go for it.
I'm going to steal the slide. Thanks, Tony. And I'm going to turn on my camera. Hopefully you can see my screen.
Yep.
Well, there will be a recording of tonight's meeting and will be available to our SMPTE Toronto YouTube channel. It's a little bit of housekeeping. Please tell your friend to become an SMPTE member or become a friend. Also, you can find all our video on the YouTube channels at GOOGLBOLWOG. And you can have all the updated information on SMPTE.org or become a friend at the ePural.com and connect with us with Twitter and email. Also, I would like to thank all our presenters, Karen, Maren, Vinicius, Stephen, Rogers, and especially also Sylvano Enor to moderate this presentation. And I will say it's been a great fun. I hope you learned a lot of things tonight, and I look forward to see you on the next meeting. So good night.
Night. Thank you.
Thank you.
Good
Good
night.
night. Thank you.
Thank you.
Thank
Good
you,
night.
everybody.
Thank you.
Bye-bye.
Take care.
Great job, everybody. Thank you.
Thank you.
Thank you.